this video, we are going to do the experiment 4, which is the 8-bit interrupt on change. So as already seen, we already created the project. So now it's time to open our MP Lab Code Configurator or MCC. It's still loading. So as usual, let's click save. And now we are going to set up our input and output pins on the pin manager. So to guide on which pin it is located, select the appropriate package, which for now I'm using speed 40. And now for this part, uh, for port A4 or port A port 4, we will select it as an output, which is in pin 6, while the port B4 we will be selected as input, which is at pin 37. So everything is set, so we will proceed to our pin module section. As usual, we only see this thing. So first, we will rename those pins. This one is a D2 LED, and this one is SW1 or switch 1. So click the output box and we will uncheck the analog since we are using a digital output. And for the switch, we will handle tweak the IOC. The IOC should be set on negative. So now we are going to proceed to our system module. So as we already did on previous experiments, we will set it to high frequency internal oscillator, 4 MHz of internal clock, and a clock divider of 4, and enabling the low voltage programming enable. Then now, we will proceed to interrupt module since everything in the system module is set. So in this setup, the interrupt will be automatically set up because it is enabled earlier in our pin module. So as we can see, the IOCI or interrupt on change is already enabled since we already enabled it earlier. So now everything is set, so we will click our generate button to generate the MCC file. We'll close this first. We are here in main.c file. So we will enable the global interrupts and the peripheral interrupts. So like on the previous experiment, which is the timer 0, we will remove the 2 slashes on the front to enable the global interrupt and the peripheral interrupt. So when everything is set, we will find the or locate the pin manager.c, which is here in MCC generated files and pin manager. So as we can see, there are a lot of codes, but we will concerning the default interrupt handler. So here is our concern, which is the default interrupt handler. So we will put our code here. But for this experiment, we will use the LED toggle. So dito, so now we are using the LED to LED toggle. So this means that in every change or in every change, the LED will toggle or will change its state. So this is the thing that we need or to modify our code for this experiment. We will click the build. So now our project uh, is building. So it says that build successful. So it is ready to insert it or uh, upload it to our IC. Now the code is being uploaded. Uh, we can test our circuit. So the blue and black wires are connected to the ground. The red wire that is adjacent to the black wire, which is the VDD, is connected to positive 5 volts, and the other red wire, which is connected to pin 37, is the input. The the output pin is directly connected with the resistor in series with the LED. So if we press the button, the LED turned on. If we press it again, the LED turns off. So the interrupt of change will be according to the current state of the LED. So if we press it again, the LED will turn off, and it will press it again, the LED would turn on. Turn off, turn on. We will create a new project again, enable to program our interrupt of change with multiple output or LEDs. So we will click the MCC to configure those input and output pins. As we can see, it is already loading. As usual, click save. Okay, let's see. Okay, here. So save. So, okay. So let's go to the pin manager grid view and set it to our current package. So we will set our uh, input here in our output here in uh, pin 6 uh, in port A, which is here in pin 6, the output, and for for another output which is set here in port A5 or pin 7. And now for our output, we will set it here in port B4, which is here, the input. So now everything is set, so we can close this already. And let's go to the pin module. So we will uncheck the analog and rename this uh, port. So we will rename it as D1 LED and D2 LED respectively. So D1 underscore, and this one is D2 LED. And this one will be named as switch 1. So we will tweak this IOC and click negative. So if we're wondering why it is always set in negative, as we can see, our switch is connected to ground. This means that by default, it has a voltage of 5 volts, and when the button is pressed, it creates a pulse which drops the voltage to 0 volts. That is why the IOC is negative, and the opposite of it is the positive, where there is no voltage by default, but if we press or apply a pulse, it will create a pulse with the amplitude of 5 volts. So that is why it is set in negative, because to create a negative pulse or to drop the voltage to 0, enable to detect that it is being connected to ground. So we will set in the system module, which is here, high frequency internal oscillator with the internal clock of 4 megahertz and clock divider of 4, and enable low voltage programming enable. So in our interrupt module, so everything is set, so we no need to worry it, so we can generate the code. So as we can see, the generation is complete. So we can go to our projects, source file, and main.c. So as like we did earlier, we will uncomment the global interrupt and the peripheral interrupt enable. So they're already uncommented by removing the two slashes. So we will proceed to our pin manager file, which is found here in this generated files at pinmanager.c. So this is the file. So here we will tweak this again, this interrupt handler. So we will toggle both LEDs at the same time. As we can see, we already programmed the default interrupt handler by toggling both LEDs at the same time. So now the code is set, so we can build this code now by clicking the hammer icon, and we can see if there is some errors or it is successfully built. So as we can see, it is successfully built, so it is ready to upload it on our IC. So we can see the code is already uploaded. The LEDs are connected to the output pins while the switch is connected to the input pin. So when we press the button, Yeah, the LED lights up. When we press the button again, the LED turns off. So let's try again. Turn the LED turned on. The LED turns off again. Uh, Turning on. Then uh, if we press the button again, the LED turns off. So we experience some delay, and it happens when we try to test this circuit for this setup. So but still we can able to apply the interrupt of change. So here it stabilizes to turn on, and if we press it again, the LEDs are blinking. Now we can see that the LED turns off. Hope you like this video, and see you again next time.